Now coming to the low cost hot metal, which is supposed to be a huge burning topic in blast furnace. As we can go through this slide, which says that low cost hot metal is not just about reducing input cost, it's about achieving operational excellence. And this slide summarizes it. Excellence across five critical parameters. And what are they? Let us one by one we will try to introspect. We start with a coke rate under 300 kilograms per ton of hot metal and push PCI level above 200 kg per ton hot metal. With oxygen enrichment beyond 30%, these fuel optimization drive down the cost. To keep pace, we need productivity exceeding 3 ton per cubic meter daily and availability over 95%, forming the backbone of cost effective furnace operation. As reaching these all target demands, deliberate design choices and design in a sense of all dimension. Each zone, that is hearth, belly, stack, and throat, must be precisely sized for throughput and thermal control. Campaign life beyond 20 years require reliable cooling system. As you must be knowing, with cooling system and refractory, both are good friends and they move always together. And if any one partner absent, then system become weak. As far the profile stability is concerned, this is also one of the very important aspects for campaign life. And one most important part is the automation that react to changes seamlessly and which measure the right value, and this value is to be diagnosed by a operator in a very timely fashion to take a corrective measure so that abnormal situation cannot remain for a longer time. Above all, the furnace must adapt to variable raw material without compromising performances. So, furnace should be merciful in some dimension, especially if we have a slight deviation in the raw material, furnace could take care of that. Now, coming to the critical area in blast furnace lining, and in order to have uh, a low cost hot metal production from the blast furnace, idea about this critical blast furnace lining is utmost important. Every furnace zone possesses its own risk profile. The hearth and bottom dictate campaign longevity. The two reason is under constant thermal and pressure assault. The Bosch, Bailey, and Stack deal with burden driven erosion, while the throat and armor demand high structural integrity and resistance to wear. Effective design must anticipate and defend each challenges. Now coming to the hearth and bottom design, which is supposed to be irreplaceable in terms of any part of blast furnace, and this is the area where we have to take a immense care because this area is in running condition it cannot be repaired. It is not easy. So you have to always stop the blast furnace and it costs a lot. So in view of these, we need to monitor the hearth and bottom very carefully so that there should not be any outrages and there is no loss of production. So we can say that productivity begins at the base. A large hearth volume support throughout, while shell jacket and water cooled bottoms regulate temperature extreme. Now, using graphite and silicon carbide in cooling profiles fortifies against thermal shock very nicely. Thin wall lining under 1000 millimeters helps contain stress and prevent crack propagation. And this leads to extend the campaign life from very foundation. Now coming to a slide where a lot of data is shown as a refractive material benchmarking activity. The material science shape performances as we all know. Graphite shines in fluctuation zones resisting up to 3300 degrees centigrade. Silicon carbide defends against erosion. Camote adds flexibility, absorbing stress and wear. Micropore low iron, and high thermal conductivity makes it ideal for hit heavy zones where head loads are high. Selecting the right material for the right zone keeps the entire system in harmony. And apart from that, the operation expert do also try to find out that how to adopt the operational discipline to derive these design outcomes. Now coming to the tour area, which is a very high stress zone area. The tour zone is just like a pressure cooker of the furnace. Temperature breach 2000 and even more, and dynamics loads vary rapidly, instantaneously, spontaneously. Hence, double densified graphite plus copper plate coolers provide unmatched resilience. Silicon carbide, although robust, must be avoided in isolation. It's prone to cracking under thermal shocks. The right combination safeguard both equipment and campaign life. Coming to the Bosch, Bailey, and stack, in particular lower stack region, here erosion hotspot are very prone. The upper zones contained with the erosion because here a lot of huge mechanical motions are occur and wear due to gas burden interaction also and copper strips degradation. So a strategic mix is essential. Machine copper for heat withdrawal, graphite for thermal buffering, and silicon carbide for erosion resistance. This triad strengthen wall resilience and support accretion formation, guarding against premature failure. Now we are going to look into the cooling system is supposed to be backbone of blast furnace design. Without effective cooling, all other design falter. Closed loop, high pressure system monitor thermal zone in real time, enabling proactive adjustment. By mapping head loads from bottom to throat, operators detect wear early and intervene before failure escalate. A well designed cooling system is not a support, it's the spine of campaign longevity. A smart instrumentation and control are the lifeline for this improvised design and its sustenance for 25 and more campaign interval. Intelligent control system are the brain behind the blast furnace. With level 2 modularity and operators advisory and control system, we can track heart temperature, taphole stress, stock line dynamics and pressure fluctuation in the Bosch and stack. Proactive, alert, empower team to act before fault emerge, shifting operations from reactive to predictive. So, what are the key takeaways? Delivering low cost hot metal is not a single step, it's a system. High productivity and robust design must work together. Critical areas like the hearth and tour demand the finest material, graphite, micropore carbon, silicon carbide, and enhanced cooling. A small instrumentation guides decision in real time. With this integrated approach, campaign life beyond 25 years is not just possible, it's it's really practical.